Ollin will be telling us about the network analysis of political data.
Thank you. Well, I'm Ollin Langle. I'm from Mexico. I work as a data scientist at the Ministry of Social Development. So I work for the government, and I'm going to talk about them, how bad they are. This is the QR for the repo. If you would like to check it out later, you can do that. Okay. And so the Mexican Senate won a prize for fulfilling their transparency obligations. But what does that mean? Yeah, that doesn't mean anything at all. Like, they give all the data, but no, you cannot have any insight from it because it is very, very dirty. So what we can do is to scrap and take the data in a way that we can have and grab some insights from it. So what we first have to do is to scrap the website, to check the website, what information is that useful for us, and we can do that and scrap it with these packages, Gumbo and Cascadia. On Tuesday, they gave a great talk about them, and they are great packages. Also, we can see that there's no robot.txt. I don't know if any of you have already scrapped something, but apparently you have to check if you can scrap a website. I'm banned for a lot of websites right now because I try to take all the data I want, but I cannot. So as long as they don't have one, so I decided to scrap it. So it is very slow to download the data because, it's slow. But using Julia, we can do this with multi-threading and do it much faster. And so I use my Google Cloud Computing free peer, and I used it to download very, very fast this data. And it's very easy with Julia to do so. Then I moved this data. I downloaded the data as CSV, and then I moved it to a database that is graph-oriented, which is Neo4j. I don't know if any of you have heard of it or use it. It's a great tool, and especially if you're doing network analysis, well, you should check it out because you will want to have the information just in the way that you're going to treat it. So you can do that, and as you can see here, we have a lot of relationships. This is a metagraph. It's not the actual network that we're going to analyze. We have a lot of nodes inside those nodes, and the pink ones are not actually nodes, but relations. So there's a lot of information in that graph. And we can use Neo4j JL to query the data and grab the insights from it. So now I will present, this is the mathematical model to build the network, and this is going to be a dynamical network, so this is temporal. And well, I'm not going to talk a lot about this, but you can see how we can build networks with Julia and with the package Lightgraphs JL. I don't know if any of you have used it. It's built upon being light, and it does not support nodes with names. So you have to build your own dictionaries to do so. But it's great because it's faster that way, and you have to really do the programming for that. So let me give you some information about this network. You can see that there are like 3 groups right there. And the red ones, the red ones are the party in power right now. And the blue ones are the second strength. And these right here are the ones that are the left-wing parties. But if you look closely, there's a red one here. So how did he get there? And that's exactly what we need to do. Because if I hadn't seen this network, I wouldn't have any information about this guy. But then I saw him and I was like, oh my God, he's my hero. He's voting like a left-wing guy when he's actually the one in the power. But actually it's not my hero because he was from a left-wing party and then switched to the party in power. So that kind of insight is the ones that we want to grab. And later, well, we can use, Julia is very good for linear algebra. And, well, I think some of you are physicists, so maybe you have heard about the Wigner semicircle law. And we can have communities in the networks when we don't have a distribution like that. And we are, if you look in the GIF, you can see that we don't have a semicircle distribution of eigenvalues in our networks. So I designed an algorithm for community detection on weighted networks, and it looks like that. I think it doesn't really matter right now. And we have a threshold. And our distribution, it will look like that. On production, we won't want to take all the eigenvalues because the only ones that we're keeping are the ones that are outside. So we can use the eigs function and grab only the ones that are larger than the threshold and do this much faster. But for illustration purposes, I think it's okay to do this, right? So this is how it performed, the algorithm. I'm sorry, it's a little bit small, but you can see that, like, with only the eye, you could see that there was only three groups, and that's what we found here. But we can make dynamic research analysis, and well, maybe you can see that later. It's a little bit long. It's a dynamical movie of these networks. But another package that I used, as was mentioned before, is RCOL. RCOL is a very cool package that allows you to use R inside Julia. From an API, it doesn't translate right away. So we can use ggplot and another R packages to do some illustrations or anything. And well, this is a representation of the dynamics of the groups in the network. And well, it is very important to mention how I built this. And well, I think it's very important because I used Docker. So I take I only have one dependency, which is Docker, and then I build everything upon that. And that's it. Thank you very much.